Welcome, guys, to our third chapter in our data structures and algorithm course. Here we'll be covering stacks, queues, and dequeues. So what we'll be doing is we'll be looking at the stacks overview and its implementation, queues overview and its implementation, deque overview and its implementation, and finally interview questions as always. However, if you guys didn't look at the past tutorials, that is the recursions and arrays, I'd suggest that you go look at them, especially the recursion, because the more we move forward with this course, the more recursion we'll use, especially on trees, where recursion is mostly used there. So if you do not have a clear understanding of recursion and how you do things, trees will be a hassle for you. But then now let's move on and see what stack queues and dequeues have for us. So stacks, right? So a stack is an ordered collection of items where addition and removal of items takes place at the same end, right? And the end is normally referred to as the top. The end opposite is known as the base. Items that are closer to the base represent items that have been in the stack the longest. Recent added item is in the position to be removed. Stacks used an ordering principle, LIFO, that is last in, out. So now let's look at this in detail, because I know personally for me, words, yeah, I listen to words, but then the visual representation, it boils down all those words that were long, and yeah, but then understanding this in this representation will make you understand all those long words that I just went through, right? So now let's look at the insertion on the left, right? So we here with two elements. So now look at stacks as a stack of books, you see. So when you have a stack of books, you cannot add another book at the bottom, right? Because you have to stack books from the top. You stack it from the top. So that's happening with the stack here, or the stacks data structure. So let's say we have two books here. So I want to add in another book. So when you want to add in another book, you take in that book and then you insert it on the top. So that's what's happening here with stack. So this is the top part, and then this is the bottom part. So now that you have three books in your stack, you want to remove one book. You cannot remove a book from the bottom, man. You remove it from what? The top. So that's what's happening here. So hence the recent added item is at the position to be removed. So that's what's happening here, and then you remove that item from what? The top, and then yeah. So now let's look at the implementation on the code side, and then let's see how we can implement this. Okay, so now that we have our text editor, now let's see what we need for our stack, because our stack, we're making a class object, right? So we say here we'll need a push method. That is basically a method to add items, and then we need get size, and then this is getting the length of the stack, and then we need is empty, and this is basically checking if the stack is empty. And then we need the what do we need? We need the pick, that is getting in the top element or item. And then we'll need also the display. This will show all items in the stack. And then finally we'll need the removal method. Removal So this will remove the item in stack. So this is all the methods that we need for our stack. So now let's implement this object. So say class stack, and then pass it in the object. So we say we need our constructor. So we need our stack itself. That will be a list, empty list. So we say define push. So basically push is self dot items dot append dot dot append, and then you need what you want to push. So that is the data. So append that data there. And then we need the get size. So we say define get size. So that will be self, and then we return length of self dot items. And then we need our is empty to check if we have an empty stack. So we say define as empty, and then self, and then we return self dot items net. And then we need our peak, right? So define peak. So say self, no argument needed, and then we return that value. So say return self dot items, and then length of self dot items -1. And then we need the display method. Display, no argument needed, and then we just say for I, just to print everything out, for I in self, we can just say return self dot items. Just say return self dot items, and then just make a new line so that whenever we write anything else, we get a new line from this. And then finally we'll need our removal. Define removal, no argument needed, and then say self dot items dot pop. So I'm guessing you guys can see that this stack is like similar, like if not identical to a list. So but then this is basically it with our methods, right? So display peak, get size is empty, push. So now let's test it out. So let's say stack is equals to stack, and then let's say stack dot append, no, dot push. Let's say 5 stack dot push, let's say 10. Now let's say stack dot is empty. So yeah, I expect to get true from this, and then stack dot is empty, and then here I expect to get false, and then stack dot display, let's just make everything dot display, and then I expect to get 5, 10, and then stack dot removal, and then I expect 10 to remove, but then let's say stack dot peak at first. So stack dot peak, I expect to see 10, and then now let's say before we remove, let's say stack dot get size, I expect to see 2, and then finally what am I leaving behind? Okay, so everything is here. So remove and then let's display it again, and then we expect to see 5 alone. So now let's see what we get. Okay, so for let's see something. Okay, so now let's test out this and see what we get. Okay, so it's not printing anything because of the following. Let's just do this quick. So get size, let's say print, and then peak, let's say print, and then display, let's say print, and then is empty. Yes, we print that, and then push. I don't need to print. I also need to print this is empty, and stack removal. Do I need to print that? Nope. And let's print this, and then now we should get some results. Exactly. So like we said, the first one is empty, is true because we have our stack empty, and then we push in 2 elements, that is 5 and 10, and then we check if it's empty, and then now it's false. And then we display our elements, that then it will be 5 and 10, and then we pick, and then that is our 10, and then we get size, that is 2, and then we display, that is 5. So now let's go through this implementation one more time for clarity. So yeah, basically this is a constructor, and then here this push is basically append the same way we append on a normal list, and then get size the same way we get the length of a size on the list is the same way. So yeah, we're checking if this is equal to an empty list, hence the true and false interchangeably. When this is empty, it will be true. When this is not empty, it will be false. And then the peak, we're looking for that last element which was added, which is the top element. So the top element is the last element which is added, right? So hence we pick like that. And then display, which is displaying the list, and then removal, which is pop. So this basically stacks just personally how I look at this. Stacks is basically a fancy way of how people who came up with stacks wanted to like not use lists. So that's how I look at it. Don't quote me on that, but then either way, I hope you guys liked this video and learned. Please like, share, and subscribe. Hoping to see you guys on the next lesson on queues. Goodbye.